Good morning, everyone. This is Sachin Piske from Electrical Engineering Department, SND College of Engineering and Research Center. The previous lecture we discussed about the frequency domain analysis and basic concept related to frequency domain analysis. We just discussed about the polar plot in the previous lecture. Today we are moving towards a Nyquist plot. So encirclement is the basic concept of Nyquist plot. Let us see what is encirclement. A point or a region in a complex function plane is said to be encircled by a closed path, and if it is found waved inside the path that is corresponding of the direction. So what is encirclement? A point or a region in the complex function plane is said to be enclosed by a closed path if it lies to the right side of the path under the path is transferred in a prescribed direction. Let us see these two diagrams shown on the screen, that is A and B. In both figure A and B, the point X is encircled but not pointy. So in this figure A, point X is enclosed, and in figure B, point Y is enclosed. Note that in polar plots, if the circle point -1 plus j0 is not enclosed, then the system is said to be stable and vice versa. Now, what is the principle of mapping in case of this Nyquist plot? The mapping theorem states that every point in S-plane will get a map onto the corresponding point in P of S or G of S H of S. The plane where P of S is any function of S. The correspondence between the point in two planes is called a mapping of a transformation. Let P of S is equals to S plus 2 for any function. See this diagram. Let P of S is equals to S plus 2 for any function. Therefore, this P of S is equals to 2 at S is equals to 0. Then P of S is equals to 2 minus 5j at S is equals to minus 5j. Once again, you have to note that this polar plot are also example of the mapping. G of S into H of S is equals to 1 upon 1 plus S, or G of S into G of J omega into H of J omega is equals to 1 upon under root of 1 plus omega square. So there are every point in the S plane that exists a corresponding point complex, that is P of S is equals to or P of S or G of H into H of S plane. During the process of mapping, the independent value S is varied along a specified path in S plane, and the corresponding path in P of S plane are joined, and this completes the process of mapping from S plane to P of S plane. For Nyquist stability plot, the map locus is called as Nyquist plot. Then, what is principle of argument? Yes, the mapping obeys the principle of argument, which state that the total number of encirclement, that is n, taken positive for particular direction of a critical path made by a closed continuous loop in P of S plane. Map from a closed S path continues is equal to the number of poles P in RHS of the S plane minus the number of zeros Z in RHS of the S plane of P of S enclosed by the S plane continuously. So what is the value of n? As per this principle of argument, this n is equals to p minus z, where this n is equals to number of CCW n circle made of the critical point, that is equals to the positive for p of s continues having CCW direction and negative for p of s continues having CC direction. P is number of poles of P of S lying in the right half of S plane, and Z dash is the number of zeros of P of S lying in the right half of S plane. Nyquist criteria can basically be applied on both open loop transform the function and closed loop transfer function. And for open loop transfer function, the characteristic equation is 1 plus g of h of s is equals to 0. That gives us the value of g of s and h of s is equals to minus 1. That is minus 1 plus j omega or minus 1 plus j0 is taken as critical point. For closed loop transfer function, P of S is equals to 1 plus G of G into H of S is equals to 0. That is, origin is taken as critical point. Consider the characteristic equation of output closed loop system. That is, P of S is equals to 1 plus G of S, H of S is equals to 0. This This is all about the Nyquist system, Nyquist plot in frequency domain analysis. Thank you.